Okay, this is the third time I'm trying to make this video. So, dogs barking, phones ringing, etc. Forget to push it up, whatever. Okay, hope you all had a good weekend. I told you we were going to be circling back to 11.7, so we did, and here we go. All right, so today we're adding on to a similarity proof. This is called product of the means equals product of the extremes. It comes right after in similar triangles, corresponding sides. You can't say parts because the angles are congruent, not in proportion. Corresponding sides are in proportion. All right, so we would have something like A over B equals C over D. All right, by definition, the extremes are the first and last. So in this case, A and D. The means are the two middle ones, so the second and third. In this case, B and C. So A and D are our extremes, and B and C are our means, just in this proportion. If I turn it upside down, they switch places because that's what happens when you cross multiply. So product of the means equals product of the extremes means A times D will equal B times C. Okay? So when we cross multiply, we get A times D equals B times C. We could also say B times C equals A times D, but that's just switching it on the other side of the equal sign. Okay, so let's try one of these. This does get a little tricky because they don't tell us which triangles to prove similar. So the first thing we have to do is figure out the proportion that came before this last statement. All right, so if it was cross multiplication, it had to be CE times ED equals AE times EF. All right, so now when I mark this, I'm going to mark this a little bit differently, and you'll see what I mean. All right, so CE, I'm going to go solid on that one, is to AE. I'm going to squiggle that one. Equals AE, equals EF, so I did solid first, to ED. All right, so in this situation, we have the triangle AED and a triangle CEF. Okay, so it's not all, they're not the same color sides, but they are the corresponding sides. So we need to prove this triangle similar to this triangle. So let's go see what information they gave me. So triangle similar to triangle, and that's what we have to figure out. All right, CD and AF are altitudes. So CD is an altitude. That gives us a right angle there because altitudes are perpendicular. And AF is also an altitude. There's my right angle for this one. So let's call those 1 and 2. We know we're going to need to say that those two are congruent to each other. Then we're going to have the vertical angles, 3 and 4. All right, so the triangles are going to be similar by angle, angle, congruent to angle, angle. All right, so let's name the first triangle. So if I call it ADE, I need to call the other one. Well, I went nothing, right, vertical. So I have to go nothing, right, vertical. Okay? All right, so this is going to be our last step. This is going to be our second to last step, and this is going to be our third to last step. So we have to get those angles congruent to each other. So I'm going to copy that. La, 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 given. All right, now, because it says it's an altitude, I have to spit out the definition of altitude. So I'm going to have to say that CD is perpendicular to AB, and AF perpendicular to BC. Right, altitudes from vertex perpendicular to opposite side. All right, now I can say they're right angles because I know they're perpendicular to each other. So angle 1 and angle 2 are right angles because perpendicular lines form right angles. And now I'm going to say they're congruent to each other. Angle 1 congruent to angle 2 because all right angles are congruent. Okay. Now I'm going to get the verticals. Angle 3 congruent to angle 4. And that's because vertical angles are congruent. All right, now the triangles are similar by angle, so I'm going to copy this because that's my third to last. Triangle ADE is similar to triangle CFE, and that's because of angle, congruent to angle. All right, now I'm going to do the proportion. CE is to AE as EF is to ED, and that's because in similar triangles, corresponding sides are in proportion. Number 8. So there's my last step, my ta-da. So EE times ED equals AE times EF, and that is product of the means equals product of extremes. Okay, so not horrible, but definitely taking it one step further. Okay, now let me make sure this is back in the picture. Okay, all right, again, I want to set myself up here. So I'm going to do it down here because I have some room. And let me make sure it's in the picture. It is, good. All right, so before I do the product of the means equals the product of the extremes, I need the proportion. So EA times CB, there's my cross multiplication, you see it? Equals AF times DB. All right, now I'm going to mark my picture because I need to figure out which triangle is similar to which triangle. Okay. EA to AF. Okay, I'm going to squiggle that one. DB. Okay, I went solid squiggle, so I'm going to go solid squiggle. DB to CB. All right, so in this case, they gave us two sides of each triangle in the same color. So I have my blue triangle and I have my yellow triangle. All right, let's go see how we're going to prove these two similar to each other. All right, AC is congruent to CB. So we have this whole big side congruent to this whole big side. So hopefully you see that there's an isosceles triangle here. So I'm going to call this 1 and 2. All right, I'm going to need to get those base angles. All right, then it also says that CD is perpendicular to AB. Now I have right angles on both of those, but I want this one right here. And FE perpendicular to AC. There we go. So I'm going to call this 3, and I'm going to call this 4. Okay, so now let's see how we're going to name these triangles. Let me mark the 1 congruent to 2. All right, if I call it AEF, I have to call it, well, I went base angle, right angle, nothing. Okay, so I have to go base angle, right angle, nothing angle. Okay, so last step, second to last step, third to last step. Right. By the marks, I can tell I'm using angle on this one again. Okay, good, I'm still in the picture. Statement reason. Number 1, I'm going to copy all that right here. So given. Number 2. All right, I'm going to go for angle 1 and 2 first. So I'm going to say that the triangle is isosceles. Triangle ABC is isosceles. How do I know that? Well, that's because it's a triangle with 2 congruent sides. Number 3, angle 1 congruent angle 2, because in an isosceles triangle, base angles are congruent. Okay, so now I'm going to say angle 3 and angle 4 are right angles. And that's because perpendicular lines form right angles. Number 5, angle 3, congruent angle 4, because all right angles are congruent. Okay, so I have 1 and 2, I have 3 and 4, so I have the 2 angles. So now the triangles are similar. Here's my third to last line. Triangle AEF is similar to triangle BDC by angle, angle, congruent angle, angle. All right, corresponding sides are in proportion, so we're going to back up one step. EA is to AF as DB is to CB, and that's because in similar triangles, corresponding sides, important, are in proportion. Then we're going to finish it up with the cross multiplication. So EA times CB equals AE times DB. And that's because product of the means equals product of extremes. Good? Okay, let's move on to number 3. You should see this arrangement I have here. I have the my iPad balanced on a roll of paper towels. It's ridiculous. Okay, this is important. It has to be included in your givens. All right, let's see what triangles they're talking about. So the cross multiplication is right here. So if I put ED here, I have to put DG here because that's the cross multiplication. Now I'm going to go EB and DC. All right. AB is perpendicular, so AB is perpendicular to BC. So I have a right angle here. So it kind of looks like I'm going to have to use this triangle. The question is, what's the other triangle? All right, so I need to get another right angle somewhere. Well, let's see. This is a rectangle. So I could maybe do it here, I could maybe do it here. But let's mark this up a little bit. All right, ED to EB, DC to DG. Okay, so I have the yellow triangle and the blue triangle. I'm hoping that looks pretty apparent. Now, the issue here is they're telling me that this is a rectangle. So I know that this is going to be a right angle here. But that's not inside the triangle that I want. So I'm going to have to get this as a right angle also. So I'm going to call that 1. I'm going to call that 2. I'm going to call that 3. All right, now, where am I going to get the other angle from? Well, I used the property that it was a right angle. Now, I'm not sure if you take a minute to think about this because I'm going to jump right into it. Check this out. Also in a rectangle, the opposite sides are parallel to each other. So I have parallel, parallel. Now if I use BC as a transversal, so everybody sees the pink, I hope. This angle right here corresponds to this angle right here. So what am I up to? 4 and 5. All right, so there's the two angles that I want. So when I say that the triangles are similar, triangle similar to triangle. Let's go EBD. EBD. So in that case, I have to say DGC. I went nothing, right, corresponding. So I have to go nothing, right, corresponding. All right, so there's my plan. Here's my last 3 steps. If you can't get any further than that, at least you can go get a few points on this question. Statement reason. Number 1. All right, now remember when you're copying this, you must include that it's a rectangle because we're going to use properties of a rectangle. All right, I'm going to say angle 1 is a right angle. And that's because of the perpendicular. All right, I need to get this angle as a right angle, but I don't have that yet. So I'm going to say angle 2 is a right angle. In a rectangle, all angles are right angles. All right, now, because these two angles form a line, if one is a right angle, the other has to be a right angle. So that's what I'm going to say right there. Angle 3 is a right angle. if two angles form a line, and one angle is a right angle, the other is a right angle. Okay, so number 5. I'm going to say angle 1 congruent to angle 3, because all right angles. So we had to work for those right angles again. Okay, so since I'm going to use corresponding angles right here, I need to say that these are parallel before I do that. So ED, parallel. I'm going to call this FC just to extend it out. So in a rectangle, opposite sides are parallel. All right, now I can say angle 4 is congruent to angle 5. Angle 4 congruent angle 5, because if two parallel lines are cut by a transversal, corresponding angles are congruent. Okay, I'm still in the picture. Number 8. So now I have both pairs of angles, so I'm going to copy this line. Triangle EBD is similar to triangle DGC, because in similar triangles, corresponding sides are in proportion. Number 9. ED to EB equals DC to DG. Oh, sorry, hold everything. This should be 9. Just rushed that, but at least I figured it out before I went ahead with it. So that goes here, and number 8 should be angle, angle, congruent, angle, angle. I apologize. This is hard to do without you guys being here. Okay, so we have the triangles similar because the angles are congruent, and then we have the proportion. So I'm sorry, but I'm going to have to go back up here. So 10, I'm going to say this, ED times DG equals EB times DC, and that's going to be product of the means equals, this is lovely, product of the extremes. Hopefully you fit it a little better than I did. Okay? All right, let's try this one now. All right, this one looks like it's not going to be too bad because I really only have 2 triangles, so. Okay. The proportion is going to be AP, QC, PB, PC. Notice I skipped number 4. Number 4 is pretty hard, so I'm going to leave that one for last. All right, now I have to figure out the triangles. Triangle similar to triangle. AP to PB, PC to QC. AP is perpendicular. AP is, ooh, PQ. So they're talking that big angle right here. Okay. CQ is perpendicular to PQ. And AB is perpendicular. All right, so this one we're going to have to name with 3 letters. Let's call this 1 and 2. All right, but now the question is, where are we going to get the other angle? Now, I'm going to extend this out a little bit. All right, since AP is perpendicular to PQ and CQ is perpendicular to PQ, these guys are parallel to each other. All right, we are going to have to say that in our proof. All right, now, hopefully you see the Z come right there. So this angle right here, I'm going to call 3. And this angle right here, I'm going to call 4. There's your 2 pairs of angles, 1 and 2, 3 and 4. All right. But things were going to go way more smoothly than that. So statement reason, number 1, la 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 la, given. Number 2, I'm going to start right off with these 2 being parallel to each other. AP parallel CQ. And the reason is going to be 2 lines perpendicular to same line. Are parallel to each other. We've actually proved that a few times with even through construction. All right, angle 1 and angle 2 are right angles. And that's because perpendicular lines form right angles. All right, notice I actually didn't have to use this angle APQ, so that worked out well. I just used the perpendicular to the same line. And angle 1 congruent, angle 2, because all right angles are congruent. Angle 3 congruent, angle 4. If 2 parallel lines are cut by a transversal, alternate interior angles are congruent. All right, I never named the triangles here, so let's call this APB. APB. That would be similar to triangle. Well, I went from nothing to the alternate interiors to the right. So I have to go from nothing to the alternate interiors to the right. All right, now the triangles are similar. Triangle APB is similar to triangle PCQ because of angle, congruent to angle. Okay, back up 1 step, so I'm taking that step next. AP to PB equals PC to QC. And that's in similar triangles, corresponding sides are in proportion. All right, now we're going to cross multiply those. So AP times QC equals PB times PC, and that's product of means equals product of extremes. Okay, I'm going to stop this video and start another one because the last question that you have is going to take a little bit. So take a break and come back when you're ready.